Welcome to this recording, which is using marginal costing in short-term decisions, but is looking at limiting factors. Now, the definition of a limiting factor is that it's a binding constraint on an organisation, commonly called a key factor. It prevents indefinite expansion or unlimited profits. So some examples of limiting factors might be there is a limit to the amount of goods an organisation can sell, or there's a limit to the amount that are demanded. It could be that there is a shortage of materials, and this prevents the organisation from making as many products as they would like to make. There could be a shortage of labour. So again, the organisation would be unable to make as many products as they would like to make and sell. It may be a shortage of space, so they can't make as many products as they would like because they have nowhere to store them. It could be machine capacity, or it could be financial resources. But whatever the limiting factor is, an organisation is always going to want to maximise their profits. And in order to maximise profits, they need to maximise their contribution. So when there is a limiting factor, an organisation needs to decide how best to use that limiting factor in order to maximise contribution and profit. So we'll have a look at an example. So we have a firm producing two products, the alpha and the gamma, and the production process includes them being spray painted. So if we look at the alpha, we're selling it for £10. It has a variable cost of £6. So the selling price minus the variable cost equals contribution. So we get £4 contribution from the alpha. Selling price minus the variable cost for the gamma equals contribution of £7.50. So we can immediately see the gamma makes a much greater contribution than the alpha, and therefore if there were no restrictions, no limiting factors, if we wanted to maximise our profits, we would maximise our contributions and concentrate on the gamma rather than the alpha. However, what if the capacity of spraying is limited to only 45 hours? Is this a problem? If we look at the alpha, every alpha needs an hour of spraying time, and the gamma needs 3 hours of spraying time. We only have 45 hours available. The other thing we need to consider is how many alphas and how many gammas are we producing to know whether 45 hours is sufficient time or whether this is in fact a limiting factor. If we look at the maximum demand for the alpha, it's 33 units, and the maximum demand for the gamma is 20 units. So we'll use that information. So to produce alphas, we want to produce 33 of them. They each take an hour of spraying, so we need 33 hours spraying time. The gamma, we want to produce 20 of them. They take 3 hours, so that is 60 hours. So in total, 93 hours of spraying time is needed if we are to meet the demand for both of our products. Now, it's suggested that we only have 45 hours. So that means we have a shortfall of 48 hours. So we know that we are limited as to what we can do by the amount of spraying time that we have. To meet our maximum demand, we need 93 hours spraying time. We only have 45 hours spraying time. So the question is, what do we do with that spraying time? Do we produce alphas? Do we produce gammas? Do we produce a mix of both? Well, we know that we always want to maximize our profits, and therefore we need to maximize the contribution. Now, there are a number of steps that you need to go through in order to arrive at the optimum production plan. So step number 1 is to identify the limiting factor. What are we short of? Well, we know that. We know that we have a shortage of spraying time. Step number 2 is to calculate the contribution per unit for each of our products. Step number 3, calculate the amount of the limited resource we require for each of our products. Step 4, calculate the contribution from each product per unit of limiting factor. Step 5 is to rank the products in order of production, starting with the one that has the highest contribution per unit of limiting factor. And finally, step 6, maximize your products in rank order until you've used all your resources up. So we're going to follow those steps with this example of alpha and gamma. And I strongly suggest that if you're looking at a limiting factor problem, that you always follow these steps. So we have the alpha and the gamma. So if we go back to the steps, step 1, identify the limiting factor. We've done that. Step 2 is to calculate the contribution per unit for each product. So for the alpha, in this example, the contribution is already calculated. £4 for the alpha, £7.50 for the gamma. So this is step 1. So this is the contribution per unit, and actually it's step 2, not step 1. Step 1 was the limiting factor, which we know is spraying time. Step 3, we've done 2. How much of the limited resource do we require for a unit of each product? So we know our limiting resource is spraying time. How much spraying time do we need for an alpha? How much do we need for a gamma? So here it's given to us. We need an hour and 3 hours. So 1 hour and 3 hours. So this is the amount of limited resource required per unit. Now we need step 4. So if we go back to our steps, step 4 is to calculate the contribution per unit by the amount of limiting factor we need. So in other words, what we're doing is dividing our step 2 figure by our step 3 figure. So this is the contribution per unit of limiting factor. And it's actually step 2 divided by step 3. Step 2 is the contribution per unit, and step 3 tells us how much of the limiting resource we need per unit. So the contribution per unit of spraying time is £4 divided by 1 hour. And with the gamma, it is £7.50 divided by 3 hours, which gives us £2.50 per hour. So we're dividing the contribution per unit by the number of hours per unit. Step 5. Rank the products. So we start with the highest down to the lowest, and by ranking them we just mean number them. So since the alpha gives us £4 contribution per hour and the gamma gives us £2.50 contribution per hour, we're going to produce the alpha first and we do the gamma second. So that's the ranking. And finally, step 6 is to work out our actual production plan. So how many of each product are we going to produce? So it's worth doing this calculation in a small table. So for step 6, we've got our products. We need to consider how many we're going to produce. We need to consider how much resource we're going to use and how much we will have left over. So looking at products, we identified alpha as number 1, so we produce the alpha first. How many of them are we going to produce? We are only going to produce up to the demand. So if we go back to the information we have, the demand for the alpha is 33. So we will produce 33 units. How much resource will that use up? So we're talking about our limiting factor, so the spraying time. If we do 33 alphas, how much spraying time will we use up? Well, we know from step 3 that the alpha takes an hour. So if we do 33 alphas, we will use up 33 hours. So what does that leave us with? Well, we were told that we only had 45 hours available. If we use up 33 producing alphas, we have 12 hours left. Now we need to use up all of our spraying time. If we've got 12 hours left, we don't want to produce any more alphas because there is only a demand for 33 of them, so there's no point in producing more. So we can now look at the product that we ranked number 2. So that was the gamma. We ranked that number 2, so we can produce some gammas because we've got some spraying hours left. Now the demand for the gamma is 20, but we know we haven't got enough spraying time to do 20 of them. We worked that out right at the start. That's why we know we have a shortfall of 48 hours. We can't do 33 alphas and 20 gammas, not with 45 hours. So we know we're going to do the 33 alphas. How many gammas are we going to do? So we have 12 hours of spraying time available. If we look at what we know about the gamma, each gamma takes 3 spraying hours. So we can use that information. 12 hours available. Each gamma takes 3 hours. Therefore, that means we can produce 4 gammas. That's used up the 12 hours and we've got nothing left over. So there's your calculation. With 45 hours of spraying time available, we will produce 33 alphas and we will produce 4 gammas. That will maximize the profits. Sometimes a question may ask you then to calculate the contribution from this mix or calculate the profit from the mix. The easiest and quickest way to approach this we are producing 33 units of alpha. Multiply that by the contribution per unit. And you will have calculated this. It was step 2. Alpha gives us £4 per unit. Right, remember we're talking about the number of units we're producing, so we need to pick out the contribution per unit figure. The gamma gives us £7.50. So 33 alphas, each giving us £4 contribution. And the gamma, we're only producing 4 units of gamma. Each unit earns us £7.50 in contribution, so that's £30. So total contribution £162. That is the maximum contribution you can earn using the 45 spraying hours. If the question had asked for profit, we have a contribution. And remember, to get from contribution to profit, you need to deduct fixed costs. So that's how you deal with a limited resource. So a number of steps to go through. So I strongly recommend you learn these steps. Firstly, identify the limiting factor. Step 2, calculate your contribution per unit for each of your products. Step 3, calculate how much of your limited factor you need for 1 unit of each product. Step 4 is the contribution per limiting factor. Step 5 is then to rank them, so to number them. And step 6 is to work out exactly how many of each of your products you can produce. So if you can get used to using those steps, try and lay it out in a similar way to I have just gone through here. So we have the contribution per unit, step 2. How much of the limiting factor we needed for 1 unit of each product, step 3. That then makes step 4 easy to calculate because we just divided step 2 by step 3, 4 divided by 1, £7.50 divided by 3. Then we rank them, which just literally means numbering them from highest to lowest. And then finally, another separate little table to work out, given the order of production, so we know that alpha was number 1, gamma was number 2, how many of each we could produce in order to maximize the profits. And then if a question does ask you to go on and calculate contribution or profit, quickest and easiest way to do that is to work on the contribution per unit method. So I hope that's helpful and will enable you to tackle limiting factor questions.